so we're going to do something similar this week that we did last week, where we're going to learn a couple new tools, and then we're going to work together to use these tools coding. So that's the deal. And first off, let's do a little bit of a review. So last week we went over for loops. So these are really important and really cool, and we saw how they can work in lab, and we also saw they could work in class. But let's just go over them again really quickly. So here's a pretty simple for loop. It's got a few parts to it. It's got this keyword here, for. It's got these conditions here, the 3 conditions of the for loop, which are encompassed by parentheses. And then it's got the block of code down here that you are actually going to loop over and execute multiple times. In this case, it's just a simple print line, which prints out the counter variable. So let's go over these 3 conditions again. So the first one is declaring a new counter variable, which is typically going to be an integer, and it's typically going to start at 0. But we saw in lab that you can start it wherever you want. And then our second condition, after you have a semicolon to end your first condition, is going to be the Boolean condition, which determines when your for loop will terminate, or when it will stop executing, and when code below it will be given a chance to execute. And this is a typical Boolean condition where you say the counter variable is less than a maximum cycle number. And so as long as this is true, this code down here, the block of code, will be cycled over and executed every iteration of the for loop. And then as soon as this goes false, the execution will stop, and we will continue with the rest of the program. And then the third and final condition of the for loop is this updating of the counter variable. And we learned last week that this ++ shortcut simply means add 1 to the value of the variable. So this is a pretty typical update condition, just adding 1. But there are instances when maybe you'd want to add 2, or times it by 2, or get really creative like that. But this is kind of your standard, nothing fancy, just basic for loop. So before we go on, does anyone have any issues with that? Everyone's got that pretty well understood? Yep. Okay. So this is really good. This is a really powerful way to code and to do many calculations without many lines of code. Now, there's one issue with this, and that issue is, what if we're unsure of how many cycles we want to do? What if we're unsure of how many cycles we need? Now, an instance of this situation in real life would be, let's say you're going to the bathroom, and there's someone in the bathroom. Now, you don't necessarily know how long they're going to be in there for, doing whatever they're doing. All you have to do is wait until they leave, right? So this is kind of an instance of a situation where you don't know how long you're going to be waiting. You just know you have to wait until something happens, right? So this is something that we can't really do with for loops, because all we can do is set an initial condition and an update condition, and then wait for those things to happen, and then the for loop is over. So we need a new tool. And this new tool is going to be while loops. Now, while loops are really, really similar to for loops, and they can be used interchangeably to some extent, but they are different in one essential way. So this is that they allow us to loop for an indeterminate amount of time, or an indeterminate number of cycles. So instead of having a determined number of cycles, now we can do it until something happens. Now we can iterate over a block of code or cycle over a block of code until a condition is met. So this is what a while loop looks like. Here we are. It looks probably really similar to a for loop. As you can see, it's actually a little bit simpler, but let's just go over each part of it. So we've got our new keyword here, while, just like in English, pretty simple. Then we've got our single condition. Now this is a Boolean condition, just like a Boolean condition of an if statement, or just like the Boolean condition that's the second condition of a for loop. Now this again is encompassed with parentheses, and then we have our curly braces, which denote our block of code down here, which will be cycled over. So can anyone see what this loop is doing here? Obviously, these methods are not disclosed to us. We just have to assume that they do what they sound like they do. But basically what's happening is we're going up to a door. We're saying, as long as this door is locked, ring the doorbell, wait for a response for 10 seconds or 10 whatever units of time, and then go up here, check and see if the door is locked again. If it is locked, ring the doorbell again, wait for a response for 10 seconds, over and over and over again until this condition becomes false. So until the door is no longer locked. And then we will skip down here below the loop and continue with our program. So can everyone see how this is kind of different than the for loops and what distinguishes it? So it's very similar in structure, and you can actually use the two. By the way, there's a meeting downstairs if that's what you're looking for. Okay. All right. So any questions on while loops? We're gonna. It's really similar, and I bet you've already got it pretty much figured out if you've got for loops figured out. Yeah. Yeah. Like a counter. Yeah. So, like basically, you could use the while loop exactly like a for loop. If you declared an integer up here, and then you said, "While that integer is less than 10," and then down here you did I++ or whatever your integer name is, ++. But the for loop kind of just makes it a neater package for you and allows you to kind of consolidate your code. But basically with while loops, you don't actually even need for loops, but it's just a nicer thing to have. But yeah, I taught you guys for loops first because it's much more common that you're going to be using for loops, but there are instances when you need to know how to do while loops. So that's the idea. But there's one problem when we get into while loops, and that is the dreaded infinite loop. So this is a situation where the Boolean condition of your while loop never becomes false. So in this instance here, where the door would never become unlocked. Now, when that happens, basically you just get stuck right here. You keep on ringing the doorbell and waiting for a response. You keep on doing that forever. Because your program doesn't have any common sense. It only has the sense that you give it. So that's going to be kind of an issue because your program is essentially going to be stuck. And it's really annoying because it's really hard to pinpoint what's going on because you don't get any errors. It's not a error per se, but it is probably not what you intended. And this used to be something that caused computers to freeze, and obviously that's a really annoying problem because then you have to restart your computer. But now, fortunately, our operating systems are getting more complex, and they're able to kind of switch things out and realize when things are going wrong, which is nice. But it's still not a good news for your program because you're going to have a program that's essentially frozen. So there's that. So careful of infinite loops, and be mindful of that. It's possible for that to happen. So if you've got a program that's just not responding to you and not doing anything, that's probably your problem. So check your while loops. All right. So that's while loops. And now that we've kind of gone over what loops are all about, we have unlocked some serious power because now we're able to do thousands or millions or arbitrarily high numbers of calculations with maybe 5 or 6 lines of code. So that's really, really awesome. But with this, we're running into an issue. We're able to do our ability to do all these calculations is outrunning our ability to keep track of these calculations and store these calculations. So what are we going to do? Well, what are we going to do if we want to hold lots of data? What are we going to do if we want to hold, let's say, the first 20 numbers of the Fibonacci sequence? Well, the way you would do it now is you would have an integer variable first num, second num, third num, fourth, fifth, sixth, seventh, eighth, ninth, all the way up to 20th. And then you would have to keep track of all these variables. You'd have to call them by their name, and it would just be kind of bad. It's really bothersome, and it's going to be a lot of code to do not a lot of keeping track of things. So it's not going to do much for you, and you have to do a lot of work. And you can probably see that if we wanted to store the first 1,000 or million or billion numbers of the Fibonacci sequence, we're quickly essentially not going to be able to do it, because you just can't write a billion variables in one lifetime, keep track of them. So what are we going to do? Well, fortunately, come on. Java's got a construct called an array. Now arrays are really, really nice. And they're a little confusing at first, but they are pretty simple at their core. So what arrays do is they store a specified number of variables, all of the same type, in one location essentially. And you can refer to a specific element in this array by using the array's name and an index of the element. Now what an index is it's like a number in a book, like a page number in a book. So you could tell someone, go to page 25, and then they'd immediately know you were talking about. You could go to that page and read it, and you would understand what they were talking about. You'd get the information that you needed. So an index is the same idea. It's a number which tells you the address of that variable within the array. Now here's the funky thing. Indexes in Java start at 0, and they end at the size of the array minus 1. This is called zero-based indexing, and it's just kind of been just a convention of computer science, and there are some benefits to it, but it's really confusing when you start out, because all of a sudden you have an array that's size 20, but index 20 doesn't exist because it starts at 0, so the highest index is 19. And the first index isn't 1, it's 0, so you kind of have to shift all your thinking back one number, which is confusing. But you will get the hang of it. So you just have to kind of drill that into your head. Starts at 0, ends at the size of the array minus 1. Okay, so here's kind of the idea, a visualization of what an array is. So you've got this big chunk of memory here with 20 slots, all addressable by an index. So 20 slots, 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 19. And each one of these slots is going to hold the value of a variable. So it could hold, this could be 20 integers, it could be 20 doubles, it could be 20 strings, it could be 20 instances of a ball object. So just like you can have any type of variable, you can have any type of array. So that's the idea. Let's look at a few real-life examples of arrays. So here's an array in real life. This is a computer lab. It's actually one that I've spent many hours in, learning stuff that you guys are learning right now. And so this is a couple instances of an array, actually. So we've got an array of computers, we've got an array of chairs, and we've got an array of people. So that's kind of the idea of an array in real life. Here's another one. We've got an array of radio telescopes. So again, it's a bunch of the same object in one spot. And you can refer to any one of the objects with an index. So you could say, okay, go to the third array. And if you were starting here and you were ending here, you'd go 1, 2, 3. Or in Java, you'd go 0, 1, 2. And then you would know which element of the array you were talking about, right? So that's the idea. Any questions so far on arrays? No? Okay. So let's go over the syntax. Let's go over how you actually write it in Java. So first off, just like any variable, you've got to declare an array. So this is how you do it. It looks really, really similar to a variable declaration with one difference. So we've got the type of variable that the array is going to hold. So this is going to be a collection of integers, this array right here that we're doing. But of course this could say double or ball or random or whatever you want. And then here we go. Here's the new thing. Here's the key difference. We've got our square brackets. Square brackets. Square brackets mean arrays, in Java at least, and in most languages actually. So there are square brackets, and then we've got a space, just like you would do if you were declaring a variable. and then we've got our array name. And this is just like a variable name. It's something that you create. Again, it should probably it should probably have something to do with what it's going to actually hold. So you could probably guess that this is going to hold Fibonacci numbers. And then we've got, always in Java, our semicolon to end the line. Okay, so that's the declaration. Pretty straightforward. Let's go over the definition. And the definition is a little bit more complicated than the variable definition. So with variables, you can just declare something and then give it a value, and that's your definition, and then you're free to use that variable. You can refer to it, you can redefine it, give it a new value. But with arrays, there's one extra step. So the first step of defining an array is like this. Now this is going to look probably a little familiar to you. It looks kind of like defining an object instance. So we've got our array name, fib numbers, get, equal sign, right? New, int, array, with our square brackets here. And then the number inside the square brackets is the array size. So remember we said that an array is a specified number of elements all in one spot. Well, this is the specified number. So this is going to be a collection of 5 integers. So basically 5 integer variables all in a row in one spot that you can refer to with this array name and with an index. Yeah. Yeah, so exactly. So it would have 5 spots, and they would be indexed by 0, 1, 2, 3, and 4. Yep.
When you're calling on them, to get 0, would you just do like, say 0, or would you have
Okay, yeah. That's a good question. We're going to get into it in the next slide. Okay. But yeah, good idea. Because you're thinking, how are we going to actually use the indexing? But it's pretty similar to the stuff we're going over right now, but we'll see. So that's the first part of the definition. So does everyone see that? This is the first thing you have to do when you want to define an array. But now we've got a spot for 5 integers, but we don't actually have 5 integers. We've only got the space for them. So we need to tell the array what specifically we want it to hold. So here's one way we could do it. There's a few different ways. So we could do this. Fib numbers, square bracket 0. So yeah, this is what you were talking about, Matt. This is how you refer to the first element in the array. You put the index here, right after the array name, and you have your square brackets that encompass your index. So just like when you're giving a variable a value, you put the variable name gets a value. Well, here you do the array name with the index gets a value. So we've got 1, 1, 2, 3, 5. So this is the Fibonacci sequence, of course. So that's pretty cool. But this isn't really any better than what we had before, right? Basically, we've just explicitly defined 5 numbers. Because we didn't save any time. We just made an array. So this is probably not how you're going to want to actually define your array values. But you could do it this way if you wanted to, but it's not really any better than just having 5 variable names and then all giving them their own value. So a better way to do this definition, can anyone think of it? Use variables you could, yeah? Yeah. Use a loop? Perfect. That's exactly what you got to do. You got to use a loop. So you've got to use a for loop, which cycles for the number of times of elements in your array, or your array size, and then gives each one of those elements a value within the loop. Yeah, so that's just what it says here. And so now we're gonna do this right now, all of us. So let's get our computers up and running, and then open up Eclipse, and we will see how it's done. Okay, so we go. What? Nice. Okay. All right. Do we all have Java or Eclipse up and running, rather? So, if you guys want, you can just keep writing in your math class that we started last week. But I'm gonna just create a new project just so if you weren't here, you can kind of follow along and still not be behind. But if you want, just keep writing your math class, and you can use the same main class as last week, and it'll all be fine. But here we go. So if you do want to make a new project and new classes, that's fine. That's what I'm going to do right now. If not, then just sit tight. Screen recording software is messing with me. Huh. Ouch. Okay, I'm going to call this project array test or something. And then I'm going to create my class, which I'm going to write into, which I'm going to call array math, I guess. And then there we go. Okay, is everyone up and running, or? All right. So first things first, this is going to be kind of similar to last week. I don't think we're going to need any instance variables. And then I'm just going to make a simple constructor that just does the same thing as we did last week, just says new array math object created, just to see that the constructor is working. And then down here we've got our other methods. And okay, so first, before we get into the Fibonacci method, which is going to fill an array with the Fibonacci sequence, we're just going to create a simpler method which fills an array with random numbers. So let's just get the the declaration out of the way. So it's going to be public because it's a method. And here's something new. So we've had return types, right? And up until now, it's been either void or a variable type. But now we're also able to return arrays. So in this instance, we're going to return an integer array. So this is how you do it. Int array, like that. So it's just like the other return types, but now you've got the square brackets to denote that you're returning an array. And then we've got our variable name, and I'm going to call this one produce random number array. Oh, that's a really, really long name, but I guess it's fine. And this is going to have one parameter, which is the size of the array. So the number of random numbers to produce. I'm just going to call it size array. And there we go. There's our method declaration. So let me know when you're ready, I guess, once you've got that down. Okay, do we have that down? All right. So what do you guys think we should do first in this method? We've got the goal of this method is to create an integer array of size array, and then to fill this array with random numbers. So what's can anyone think of the first step, the first thing to do? So the first thing to do is going to be to declare a new array. So that's what we were just going over. So the way we do this, if you remember from the slides, is we declare a new int array like this, and I'm going to call mine rand array. And then I'll just do it all. I'll do the declaration in the first part of the definition all in one line. So we're going to say gets a new int array. And then, of course, the size of the array goes in between these two square brackets. And the size of the array is going to be the value of the parameter, right? So this is going to be size array. Okay. So hopefully it likes that. Okay, cool. So does everyone see that? So remember to think about what you're coding now, because this is the syntax of declaring an array in the first part of defining it too. So this is going to be something that you're going to write over and over again, and it's not too complicated, but it does take some remembering. Okay, cool. So the next step, which we may not have thought of, is that we're going to have to create a random number generator. Now, we went over this a couple times ago, but you may have forgot. This is how you do it. So we're going to use Java's random number generator, which is called random, uppercase random. I'm going to call it the variable name rand, and then it gets a new instance of the random class, right? Just like that. And then remember too, in order to use Java's libraries, we need to import them. So a good shortcut for doing that is hovering over the name of the class, which is going to have a red underline telling you that it's an error, and then just going down to the first quick fix, import random, and then remember that that just puts it up here at the top of your class. So that's a nice thing about Eclipse. But if you weren't using Eclipse, you could just go up to the top and say import java.util.random. You'd have to look up the package names that Java use, but that's how you would do it. Okay, nice. So now we've got our, yep. Okay, which part, the random number generator part? Okay, so you probably have a red underline underneath random here and underneath random here. So just hover your mouse over one of them. It's not going to work for me, but if you just keep your mouse still over it for a second, then the first quick fix, I think, will be import java.util.random. So just click that, and then Eclipse will automatically put this line up here for you, which is nice. Okay. Is everyone with me right now? Any questions so far? Okay, good. So the next step is going to be to populate this array, to give this array values for each one of its elements. Give each element a specific value. And remember, Marissa said that the best way we should do this is with the for loop, right? So now we need to write this for loop. So for loop for, and then we've got our three conditions, right? We need to declare and define our counter variable. So I'm going to use I, because that's what I usually use, but you can use whatever you want. And then, I get 0, right? So we got to start out 0. Why are we starting at 0? Can anyone think of it? It's because our array starts at 0, right? That's the 0-based indexing we were talking about. So we're going to use I to index into our array. And therefore we want I to start at 0 because our array starts at 0. So then, given that, can anyone think of the termination condition? What Boolean condition are we going to use here? I less than. Can anyone think? Anyone know? Yeah. The what? 5? Okay, yeah, we could use 5 if we were going to do the example that we were doing in the lecture, but now we're going to try to be a little bit more general. and be able to do any number of random numbers using the size array right here. So you were right, but we're just kind of building on top of what we're doing. So we're going to actually do size array, so the parameter value. Array. And then we just want to do I++, because we want to just go up by 1, just like the indexes do. Okay. Then don't forget your curly brace and your closing curly brace, which Eclipse will do automatically for you, and then we're ready to rock. So now we need to give each element in our array a value. So we're going to do it like this. So we put our array name, rand array, and then this is our first chance to use the indexing. So we're going to use a square, open square bracket, and then the index that we're going to use, like I said before, is the value of I, the value of our counter variable. So I get rand dot next in. So this is the method of Java's random number generator, which produces a random integer. We went over that a couple of times ago, but you may have forgot. Okay, so there it is. And then we've just got one more thing to do. Because we said we were going to return an integer array, we've just got to return rand array, just like that. Okay, let's clean this up a little. All right, does everyone have that so far? Now, let's talk about this for loop part for a second. So the way this is working is we've got a counter variable I, which starts at 0, and then is going to go up until size of the array minus 1, until I is less than size of the array, and it's going to go up by 1 every time. So this for loop is going to cycle for size of array number of times. So if size of array is 10, it's going to do 10 cycles. It's going to start with I equal to 0. Next cycle is going to be I equals 1. The next cycle I equals 2, all the way up till I equals 9. 10 size of the array minus 1, right? And because I is doing this nice, neat pattern, which we figured out up here, it's going to be the perfect way to index into our array. Because the first time it's going to be 0, and that's the first element of our array. And we're going to give it a random number. The next time it's going to be 1, our second element of the array, and we're going to give that a random number. Then it's going to go all the way up until, if the size of the array was 10, all the way up until 9, give the last element a value, and then it's done. So does everyone see that? That's kind of like a neat trick with the for loops. And this is this exact pattern here with using I initially equal to 0, I less than the size of the array, I++, and then using it to index into the array is a really common programming pattern that works really well with arrays. So does everyone see that? Everyone see what's going on so far? Perfect. Let's test it out. So again, if you're just using your math class from last week, then just use that main class, but I'm going to make a new main class just because I created a new project. So, what is it? Alt N class main. And then this is what I was talking about last week. You can check this box if you want to give it a main method. You don't want to write it. Or you can just write it out by hand if you want to. But here we go. So here's our main class with our main method. And so I'm going to start by creating an array math object like this. Array math space AM, I guess, gets new array math. And remember, our constructor had no parameters, so we don't need any parameters there. And now, in order to test this, I'm going to print out the value of the array after making the method call. So AM, I'm going to call the method we just wrote, AM dot produce random numbers. So if you don't want to type it all out, you can just hit enter once you've got the right method name down here. And now this is where we're going to give the parameter an actual value, so I'm going to do 10, like we were talking about. And so there we go. We're going to print out the return value of the method produce random number array, and we're giving it a parameter of 10. So we're going to hopefully, if we didn't write any bugs in our method, create 10 random numbers, put them in an array, and then return it here, which is going to be print out to the console down there. Does everyone see that? So hopefully when I run this, we get 10 random numbers. Let's see. Okay. Okay. Not quite, right? We got weird stuff going on down here, real weird. One good thing is we saw that our constructor was called, because we have this print line that we wrote in the constructor, works fine. But we've got basically gibberish right there, right? That's because you can't print out an array using system.out.println like that. You need to be a little bit more clever. Because the array is actually, that's basically like a memory address, and it's just going to look like gibberish to you because it doesn't really mean anything. So what we need to do is do the same thing we did to fill up the array. We need to use a for loop to read from the array. So what we're going to do is go back to our array math class, and we're going to write a method which prints out every number of the array. Okay? So let's do the method declaration. Public, just like every method. Since we're just printing stuff out here, we don't actually need to return anything, so it's going to be void, right? And I'm going to call this print array. Now, what are we going to want for a parameter? What are we going to need for input? We're probably going to need an array that we're actually going to print out, right? So this is actually probably call this print int array, because this will only print integer arrays, because I'm going to give it a parameter which is int array. But you could do the same exact thing for any other kind of array. It'll just be a different type right here. Okay, cool. So now let's go back to our trusty programming pattern that we just learned. For int I equals 0, I less than, okay, this is something new. So if you want to determine the size of the array, and you don't have it like we had up here as the parameter size array, down here we don't actually know. But a good way to figure it out is to do the array name, so array, then dot length. So that's a field of the array. So every array in Java implicitly has this field length that you can refer to figure out how big your array is. So in this instance, because we just created an integer array of size 10, this field array.length will be value 10. Then I++ over here. Okay. Now, all we need to do is a nice print line, system.out.println, and then array. So that's our array name, and then we're going to index into it with I, just like up here in our produce random number array method. We used I to index into it. We're doing the same thing down here because we're using the same exact pattern, just for a slightly different purpose. Okay. Cool. So now, as long as this is bug-free, we should have the ability to print out every value of the array. So, like always, when you finish something, you should probably test it. So we're going to test it right now. And we're going to say, instead of calling this, we're going to call that method. So we're going to do am dot print int array, and then, oh, okay. Well, I actually need to produce an array up here. Oh, I should do this. Okay. Sorry. We're going to first create an array, which is going to be called, I don't know, rand array. And this array is going to get the return value of our produce random number array up here. So we're going to do am dot produce random number array, and then I'll give that 10 just like before. So this line, to reiterate, is calling the method produce random number array on the am object instance, which is an array math object, and it's using the return value. It's using the array that that method returns, and it's putting it in the array variable over here, rand array. And then we're going to use this array that we just created to print out down here. And now we should be cool. Now we should get 10 nice random numbers down there in the console once we run it. So does everyone see that so far? Does everyone kind of understand what's going on with that? I know this is a lot at once, but we're going to go over this in lab and next week again too, so don't be too intimidated, but this is the idea. So let's try it out. I'm going to run it real quick. And there we go. Nice. 10, I think. Yeah. 10 random numbers, random integers. They're all over the place. Yeah. Okay, I'm sick. Okay. I think that's where did that go? So your array test doesn't have a... Oh, okay, yeah, it's the same problem you've been having, yeah. All right, I gotta figure out why that's happening. Yeah, I think like that should be cool. Stay okay, yeah. Okay. Well, you got an error now, so check that out. Oh yeah, now you got the other problem. We got to array math real quick. Yeah. Okay, yeah, so you've got a little typo. Nice. So save that real quick. Well, if you save it, I think it will go away. No, it should be totally different. Yeah. So this is running your old program, right? So just hit right click on array test, and then you go down to run as Java application. Nice. Yeah.
Why will it like let me have that as I?
Interesting. Can you scroll over it real quick? The I. Oh, go down.
Okay.
Yeah. I cannot move on. No, let's see. It should be. Oh, okay. Yeah. So it's because you have a semicolon there after the for loop instead of an open curly brace. Yeah. So just then you gotta just make a closing one below below your system.out.println. Yeah. Now you should be cool.
Thank you.
Nice. Yeah. Oh, okay. So you just got a typo. It's got to be I less than, right?
Oh.
Like that. Try that. Then over here. They should be fine now. Okay. Is there anyone else have any problems? No? Okay. This is a problem that's been coming up. It's just something with Eclipse. So if you're ever having a problem running the right project, like if your old project's running instead of your new one, all you got to do is go over here to the left to the Package Explorer, and then right-click on the project you want to run, and then go down to Run As, and then you want to do Java Application. So yeah, just a quick thing to remember if you ever have a problem running the right. Then after you do that, every time you hit run, that project will run afterwards. Yeah. Yeah, so that has something to do with the size of an integer in Java, which is like a little complicated, but basically it's going to be 2 to the 32. and then you have to half that because there's negative numbers. But basically, it's determined by the number of bits, or zeros or one, that an integer holds. But you don't have to worry about that specifically. But if you want to restrict that size, there's a method to do that with the random number generator. But it's because of how integers are actually physically stored in memory. So, yeah. Okay. Yep. Yeah, it must have just been a coincidence, which is actually pretty crazy because it had, well, 2 to the 32 numbers, which is like probably a couple billion. I don't know actually exactly what that is, but it's a lot big coincidence. Crazy. All right. So does everyone see that so far? Everyone with us still? Cool. All right. So now let's tackle the task we originally wanted to tackle, and that's going to be to store the numbers of the Fibonacci sequence. So, oh, I'm writing in the wrong class. So let's go back to our array math class, and we're going to write a third and final method in here, and that's going to be called, well, you can call it whatever you want, but I'm going to have it be very similar to this produce random number array method. It's going to return an int array, and I'm going to say produce fib array. And then, just like with our random number array, I'm going to have a size array parameter, which is going to determine how many numbers of the sequence we produce. And then this all kind of goes back to the lab last week. So it's going to be very similar in the structure where we create the numbers, and then it's going to, instead of printing them out, put them into an array. So if you remember from last week, the way we did it is we declared a couple integers. Here, we give the first two their values. Int A gets 1, int B gets 1. And then int C doesn't have any value yet. But, okay, so last week you remember we printed out A and B here. Well, now instead of printing them out, we're going to store them. So we're going to say, well, we also need to create an array, right? So int array fib array gets new int array size. What's the size of the array going to be? Anyone know? Size array, right? So just like before, we're using the parameter as the size. And there we go. We've got our empty array. Now we should put A and B in there to start. So fib array 0, the first index gets A, the first number of the sequence. Fib array 1 gets B, the second number of the sequence, and then now we're ready to enter our for loop. So I'll let you guys get that down real quick. Okay. So here we go with our for loop. So it's just going to be like in lab. Now we're going to declare our counter variable. So where do we want to start? Do we want to start at 0 like before? Well, we can start at 0, but we've already done two pieces of the work here. So where do you think we're going to want to start? We have 0 and we've got 1. So where do we want to start? 1? Okay, we can do 1, but we've already done it here, so probably just 2, right? So we'll start at 2. So our counter variable is going to get the value 2. And we're still going to do I less than size array. And then we're just going to do I plus plus. And that's our for loop. Now, does anyone remember how we created the sequence last week in lab? There was a trick, right? There was one trick we used, or a couple, I think, depending on how you want to look at it. So the first step was we put, yeah. 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 So you got the idea. So what Aiden's saying is we have C get the value of A plus B. So this is really the definition of the Fibonacci sequence. So it's the last two numbers added together creates the next number. So C gets the first two numbers added together, and then to keep everything up to date, B gets A rather. No, A gets B, sorry. And then B gets C. So this shifts our sequence forward one. And then last week right here we printed out C, but instead of doing that we're going to store it into an array. So we're going to say fib array I, right? Using our index of the for loop, gets C. Okay, so I know I'm going really fast right now. It's because we're running out of time, but we'll see this a couple more times. So don't stress about it if you're not quite with us. But then the last step is going to be to return this array. So just like that. And voila, I think our method is done. Okay. Does everyone see that? Now, let's test it. So let's go into our main class, and we're going to do something really similar here. I'm just going to kind of edit it so we don't have to write everything new. I'm just going to have a new fib array. Gets am dot produce fib array. I'll do 10 again because it seems fine. And then down here we'll just print out our fib array. Okay. Does everyone have that? So hopefully now when we run, we're going to see the first 10 numbers of the Fibonacci sequence printed out to our console. And if not, we made a mistake. But we'll see. Okay, here we go. Let's get up to the top of this real quick. All right, looks good, right? We've got 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. That's good. Looks good, right? No problems there. Is everyone getting that? All right. So that's that. So that's an introduction to arrays and using for loops to reference these arrays. Now I know that's a lot, like a ton for 1 hour, but that's basically an introduction. We'll see this more in lab on Wednesday. And otherwise, really good job today, and see you then. So good work, guys. Okay, let's see. Yeah.